Hello everyone. In this session, we are starting new chapter, that is process synchronization. So what is process synchronization and why do we need to synchronize processes? All these things we will discuss, and we will discuss some of the very fundamental things which will help you to understand the synchronization concept. So let's start the discussion. The very first prominent question is, we should understand what is the need of synchronization. So if I very first ask you what is a process? Process is a program in execution. And what is a program? Program is a sequential, or you can say the set of instructions. So there are a number of instructions we write to perform a particular task, and we consider it as a program. And when we execute the program, we consider the process. Now let's understand, there are different types of operating system. I have already discussed. So like batch operating system, multitasking operating system, multi-programmed operating system. Nowadays we use multi-programmed or multi-processing or multitasking operating system. So the meaning is, there is a provision inside the operating system to run multiple processes, or we can load multiple processes inside the RAM, and multiple processes can be executed simultaneously at a given point in time. So when multiple processes executing, every process requires certain number of resources to be executed. So if I precisely discuss what a process require to be executed, a process require few of the hardware and some resources in terms of registers to be executed. So I have already mentioned here, if we want to initiate a process inside the system, process requires the central processing unit or CPU. Process also requires a memory to load the instructions as well as data. Process also requires some input output devices like keyboard or disk or other devices. Process also accessing system buses like address bus or data bus. And there are certain registers like program counter. Program counter is a special purpose register which stores the address of instruction which need to be executed next. Then there is the instruction register. Instruction register loads the currently executing instruction. Memory address register. Process executes the instruction. So if an instruction involves some memory address as an operand, so whatever the memory at any point in time process is accessing, that memory address will be maintained in MAR. MAR is memory address register. And from that memory location, if we are or process is reading data or writing, let's say, some data, temporarily the data will be loaded in a register that is considered as memory data register. So let's say a process is reading data, this is the memory if I'm considering RAM, and from this RAM the data is being read from a particular location, let's say from here, a process is reading the data. So temporarily this data will be loaded in memory data register MDR. And there are certain general purpose register. If it is required, programmer can use the general purpose register by using register class, by declaring any variable of register class. And there is a status register also. In case there is any underflow or overflow condition occurs, then such kind of status will be set. So these are few of the things every process require. Now the point here is, when we are using multitasking or multi-programming operating system, if we are having single CPU, all these things are only single unit of these things are available. Then how we can initiate multiple processes? I hope you are getting the challenge. So either we have multiple processors, a processor unit which is having all these things. A processor has ALU, arithmetic logic unit. Processors has required registers. So every processor is an independent unit. So system can give instruction to a processor and processor can execute, right? So if there are multiple processes, more than one processes can be executed, and such kind of execution we consider as parallel execution or parallel processing. But if we are having only single CPU or single processing unit or single ALU, at a time only one process can be initiated. So generally what we do, we load the processes, multiple processes in the memory. So at a time we don't load only single process, we load multiple processes. So let's say we are loading P1, P2, P3, P4 processes in the memory like this. And in case we are having a single processor or arithmetic logic unit, then at a time only one process can be executed. You try to understand like this. Let's say we want to perform multiple tasks by applying our brain simultaneously. So if there is a task 1 and let's say task 2, and task 1 requires to perform some number of steps, and task 2 is also having some number of steps to be executed, right? So because I am single, the processing unit is single, so at the time let's say I start executing the task 1, but in a time frame I want to execute both the tasks. So let's say in this time frame I want to execute both the tasks simultaneously. So what I want, I will execute some steps of task 1, then I maintain this record how many steps I have executed of task 1, let's say 3 steps, and then after that let's say I start executing the steps of task 2. So the first step of task 2, second step of task 2 is executing here, third step, fourth step, and then again I start. So I need to store this record up to which particular step I have performed this task or executed this task, if I am just a kind of machine, not the human being, right? So here let's say I start executing the step 4 of this task 1, then 5, and so on. So it is keep on going on. So in this particular duration, from this particular duration, if I look from this side, let's say there are two tasks executing, task 1 and task 2. But if I focus on a very particular point in time, because I am having only one processing unit, there is only single task is executing. So this is not the parallel execution. We consider such kind of execution as concurrent execution. So this is concurrent execution, right? So concurrent execution is different from the parallel execution. We can execute two processes parallelly if we are having more than one CPU, right? Or it is also possible that your one CPU is having multiple cores. So when we say cores, that means all these things, the arithmetic logic unit and required registers, they are mounted on same chip. So let's say we are having dual core or quad core processors or octa core processors. That means there are different cores available on the same chip. Okay. So if there are multiple cores, at a time we can execute multiple instructions, because all those cores can be functional independent to each other. They are having required hardware support. I hope you are getting. So let's talk about the concurrent and parallel processing. In concurrent processing, if I depict with the help of a picture, so let's say time is moving like this, and I'm starting two processes. So let's say P1 is executing here for a certain duration of time. I'm considering this is P1 process, and P2 is executing, let's say here. So if there is only single CPU, when P1 is executing, P2 cannot execute, right? So let's say P2 is executing in this duration from here till here, let's say, and then P1 again start executing. When P1 is executing, P2 cannot execute because I'm assuming there is only single CPU. And if I want to execute P2, then I need to preempt the P1, execution of P1, right? So it can execute for a certain duration of time. And let's say again, I start executing the P1, right? So if we look for this particular interval from the beginning, let's say I consider this is t is equal to 0 till let's say t is equal to any moment I. In this duration, there are two processes are executing, P1 as well as P2. But any given point in time, because there is only one processing unit, only one process is executing, right? Now, why we need synchronization? I'm just try to highlight that point. When these two processes are executing, these processes are executing some set of instructions. And instructions is the combination of two things. Every instruction has opcodes and operands, right? So when we execute an instruction, it may require some operands or data, right? So the instruction of a program or a process may be interdependent or may be independent, right? So a single program can be divided into subunits or sub blocks. Those are independent to each other. So if we can divide some instruction or set of instructions in a program, those are independent to each other. And if we are having parallel processing architecture, every instruction we can execute parallelly, and in that way we can speed up the execution of the program, right? So let me take some example and then you will be clear on this. So let's say a process or a program is having some set of instructions or statements. So let's say I'm writing some statements. Let's say I'm writing a statement S1, and S1 is having a statement like this, that it is evaluating or calculating the value of, let's say, A, and A is having two variables, and based on these two values, the value of A is being calculated. There is another statement, let's say S2, and S2 is being calculated, or let's say it is calculating a value of B, and it is involving a variable Z, let's say Z plus 1, or okay. There's another statement, let's say S3, and S3 is calculating the value of, let's say, C, but C is being calculated based on A plus B, let's say. So we are considering A and B, and then we are calculating. And let's say there is a statement S4, and in S4 we are trying to calculate D, and D is, let's say, C minus 1. So these four statements are there. Now if we try to find out, in case we are having parallel architecture support, or we are having, let's say, multi-core architecture, Can we execute these four statements parallelly? To decide this, or you can say concurrently, to decide this, we need to check some of the things. So in every instruction, some of the variables or memory addresses will be read, and some of the memory addresses or location will be updated. So every instruction involves some variables. So there are two sets of every instruction we can find out. One set we consider as the read set of an instruction. So if we calculate the read set of, let's say, S1, the read set of an instruction is the variable those are being read or accessed. So in S1, we are reading the value of X and Y. So I am saying the read set of S1 is having X and Y. And if I consider read set of S2, S2 read set is having variable Z. Okay. And read set of S3, read set of S3 is reading variable A as well as variable B. And if we find out the read set of statement 4, the read set of 4 is only reading one variable, let's say C. Okay. Now along with the read set, there are certain another variables, those are being updated. We consider those set as the write set. So if we find out the write set of S1, S1 is updating only one variable, that is A. So write set of A is having only one variable, that is A. And write set of S2, S2 is updating only one variable, that is B. So write set of S2 is having B. And let's say we have write set of statement S3. S3 is updating one variable, that is C. And write set of statement S4, it is updating the variable D. So we do consider read set and write set of each and every statement. What we are trying to do is, we are trying to find out whether we can execute these statements concurrently, parallelly or not. Okay. Parallel execution means the statements will be executed on different machines or different processing units, right? And concurrent execution means in the same time frame, the different instructions will be executed on the same machine. Okay. Same core or same processing unit. Now, to decide whether S1 and S2 can be executed concurrently or not, we need to check the intersection of read and write set. So if we want to check whether S1 and S2 can be executed concurrently or not, so we need to find out read set intersection with write set, or you can say write set of one instruction intersection with read set of another instruction, or we find out the intersection of write and write set. If all these are empty, then we can say those instructions can be executed concurrently. So let's say I'm taking here S1 and here I'm taking, let's say, S2. So here I'm taking S1 and this side I'm taking S2. Here S1, let's say, and this side S2. So I'm trying to conclude whether S1 and S2 can be executed concurrently or parallelly or not, right? So if you find out the read set and write set intersection of S1 and S2, read set of S1 is having XY and S2 right set is having B, so it does not have anything common, that means it is phi. Right set of S1 is A and read set of S2 is Z, so there is nothing common, that means it is also phi. If you consider right set of S1, that is A, and right set of S2, that is B, there is also nothing common, so it is phi. That means S1 and S2 can be executed concurrently or parallelly. Okay. So they can be executed concurrently, right? Similarly, we can decide whether S2 and S3 can be executed concurrently or not. So if you look at here, A is being calculated based on X and Y, but we are not reading X and Y from anywhere, right? These are independent kind of variable. And this statement is taking Z, and Z is also not dependent on any S1, S2, and S3 and S4. So this is also a kind of independent variable here. But when you calculate C, C is being calculated based on A and B. So that means S3 and S1, if you try to find out the concurrency, the condition will not be true, because the read set of S3 will be intersecting with write set of S1 and write set of S2, because S1 is updating A and S3 is reading A. So these S1 and S3 or S2 and S3 cannot be executed concurrently. So there has to be a sequential execution of S1 and S3 or S2 and S3. Now if you try to find out whether S3 or S4 can be executed concurrently or parallelly or not. So we again check this D is getting updated based on value of C, and C is being calculated here. So S3 contains C in the write set and S4 contains C in read set. So read set and write set conflict is there. S3 and S4 cannot be executed concurrently or parallelly, right? So if such kind of challenges are there, if one instruction is dependent on other, and if we are creating more than one thread or more than one process, and those instructions are getting copied to both the processes, how we can decide the sequential execution of those instructions? Those are interdependent. So we require some construct or some mechanism which help us to synchronize. And if we do not synchronize such kind of thing, then there will be inconsistency in the result. I hope you are getting right. So to recognize the things, which thing can be executed along with which particular instruction, we draw the precedence graph. So let's look at the precedence graph. The precedence graph, like if I consider the previous example, in previous example S1 was independent to any other statement and S2 was also independent. But based on S1 statement and S2 statement, we were calculating S3. So let's say I'm saying S3 is dependent on S1 and S3 is also dependent on S2, right? And if you look at the S4, S4 is dependent on only on S3. So if I write S4 here, it is dependent only on S3. So such kind of graph we consider precedence graph. So let me write here, this is the precedence graph. Okay. Now by looking at this graph, this is a directed acyclic graph. This is a directed graph. That's why the arrows I have drawn. It is clearly representing that before execution of S3, S1 and S2 statement need to be executed. Before execution of S4, S3 need to be executed. And before execution of S3, S1 and S2 need to be executed. So it is reflecting a kind of sequencing of instruction execution. And this is known as the precedence graph, right? So these things are required, you need to put in your mind when you are going to initiate multiple processes. We need to synchronize them. If we do not synchronize them properly, if we do not check the dependencies, there will be data inconsistency. Okay, so in next session, I'm not stretching this session. In next session We will try to understand the race condition, how the data inconsistency will be there if we do not synchronize the things. Okay. So in this session, I just wanted to highlight what is concurrency, what is parallel execution, and what is concurrent execution. What are the steps or the hardware requirement is there to execute a process? So I have highlighted here. If we initiate multiple processes in a system, what are the challenges and what is the need of synchronization? Okay, so the actual synchronization we start from the next lecture onward. So I'm just closing. Thank you. See you in the next class.